Alright, so this is problem 4.6. And the question says, an electron with a mass of 9.11 times 10 to the negative 31 kilograms leaves one end of a TV picture tube with zero initial velocity, initial speed, and travels in a straight line to an accelerating grid, which is 1.8 centimeters away. It reaches the grid with a speed of 3 times 10 to the 6 meters per second. If the accelerating force is constant, compute A, the acceleration, B, the time to reach the grid, and C, the net force in newtons. And then it also says to ignore the effect of gravity. So first things first, we have an acceleration or an electron that has a mass of 9.11 times 10 to the negative 31 kilograms. We have a distance that is equal to 0.018 meters, and it has a velocity final that is equal to 3 times 10 to the 6th meters per second. And then it asks for A, is asking for the acceleration. So we know that we have the equation from kinematics because the acceleration is constant, that velocity final q squared is equal to the velocity initial squared plus 2 times the acceleration times the change times the delta x. So we know that when we plug this in, we get 0.3 times 10 to the 6th squared. This term is 0 squared, so that just kind of goes away, plus 2 times a, what we're looking for, times the change in distance, or the change in distance, which is 0.018. And then it's just solving. So you then get 3.00 times 10 to the 6th squared divided by 2 times 0.018 equal to your acceleration. So your acceleration, when you do the math, that comes out to 2.5 times 10 to the, where'd it go? 14 meters per second squared. So that's your acceleration. It then asks for the time. So we know that acceleration is equal to the change in velocity over the change in time. Or no, sorry. We know that the change in time is equal to the velocity divided by the acceleration. This is for part B. And so we know that t is going to be equal to 3 times 10 to the 6th divided by our acceleration that we just found, 2.5 times 10 to the 14th. And we know that, and when you do the math, that gives us a time of 1.2 times 10 to the negative 8 seconds for our time, which makes sense. It's covering a really small distance at a really high speed, so it should have a really small time. And then part C asks, so C asks, what is the force in newtons? So we know that the force is equal to the mass times the acceleration. We got the acceleration there. And it gave us the mass at the beginning of the problem. So we got 9.11 times 10 to the negative 31 times our acceleration, 2.5 times 10 to the 14th. It's going to be equal to our force. So we know that that is then equal to, it's just multiplying. And when you do the math, that comes out to 2.27 times 10 to the negative 16 newtons. And so that's our force in newtons, ignoring the effects of gravity.